Today we're going to learn Pythagorean Theorem. Long time ago, back in ancient Greece, there was a man called Pythagoras. You can only imagine what it was like back then with no TV, no video games, no iPods, no cars. These guys really needed to find something to keep themselves occupied. I know my students always ask me why it is that ancient Greece came up with so much math. I'm sure that was part of the reason. So Pythagorean theorem is all about right triangles. So you have to have a right triangle before you can even consider using Pythagorean theorem on one. Right triangles, remember, have a 90-degree angle. They also have a hypotenuse and two legs, and usually we call the legs A and B and the hypotenuse C. So first of all, I'm going to show you why Pythagorean theorem works, then we'll do some examples using the formula. So first of all, I have my right triangle A, B, and C, and I have these three squares that are going to help me out with this. So first of all, I'm going to bring this big purple square up. Notice that it has the same side length as my hypotenuse C. Well, in a square, when you have one side that's C, all sides are C. To find the area of that square, I would take side length times side length, or base times height, and I would get C squared. So this purple square we're going to call C squared. Then I'm going to bring up the red square. It's the same length as B, so the area of the red square is going to be B squared. And then the yellow, notice how the yellow has side length A, same as one of the legs on my triangle. So the area of the yellow square is going to be A squared. Now we're going to use that to help us out. I'm going to move these back, and I'm going to make some duplicates of my original triangle. I'm going to make duplicates so that you can see that they are exactly the same as my original triangle, and they're all the same size. So I'm going to bring these squares together, and now I'm going to use some of my blue triangles to do a little bit of filling in. Remember that the blue triangles are all the same size. This takes me a minute, sorry about that, but you need to see why this works. So I brought two blue triangles over so far. Now I'm going to bring a couple more. This is not as easy as it looks. I know I'm not going to be able to get this perfect, but we'll be okay. So now I have my blue and red squares, A squared and B squared, and 4 blue triangles. Around those squares, let's see, I'm going to make a big black border square. There we go. So that it all fits together nicely in one shape. Now I'm going to do something similar with C squared. Let's bring over some more triangles. Let's see if I can get this to fit. Oh, I need to make one more duplicate. And there we go. So now I have another square. It's C squared with 4 of the blue triangles again. Remember, this square was a squared and b squared along with 4 of the blue triangles. So now I'm going to make a duplicate of my square border so that I know it's exactly the same size as my original square. And I'm going to bring it up and put it around my second square, just to show you that these are exactly the same size. A squared and b squared, along with 4 blue triangles, take up the same amount of space, same amount of area that c squared and 4 blue triangles take up. So this is kind of what I'm getting at. Let me turn this on so I can write. This is kind of the synopsis here. I have a squared and b squared along with 4 blue triangles. That is exactly the same as c squared with 4 blue triangles. If I take the 4 blue triangles away from both sides, what am I left with? I get that a squared and b squared added together is going to take up the same amount of space or same amount of area as c squared. And hence, the Pythagorean theorem is born. A squared plus b squared equals c squared. That's the Pythagorean theorem. That applies to every right triangle, no matter how big, no matter how small, no matter which direction it's facing. As long as A and B are the 2 legs, remember the 2 legs surround the right angle, and C is the hypotenuse. So let's look at what that does for our triangles. If I have a missing side length on a right triangle, and this is most often what you'll use Pythagorean theorem for, I can find that missing side length using Pythagorean theorem. So let's take a look. Remember that we have to name our sides. I already have B, so the other leg is going to be A, and our hypotenuse is going to be C. So that when I have A squared plus B squared equals C squared, I can fill in what I do know and what I don't. First of all, A was 3. That's one of our legs. So 3 squared plus B squared, that's the one I don't know, equals C squared. And since C is 5, I'm going to put 5 squared here. This is an equation that we can solve, right? Order of operations says I've got to do the exponents first. So 3 squared is 9 plus B squared equals 5 squared is 25. Then I'm going to subtract 9 from both sides. Our 9's will cancel, and I'm left with a positive B squared equals 16. To get rid of a squared, remember we square root. What I do to one side, I have to do to the other. The square root of B squared is B, and the square root of 16 is 4. My missing side length is 4 units long, and Pythagorean theorem helps me get there. Let's try another one. Again, I'm missing a side length or a leg length. We're going to call that A. That makes this side B and our hypotenuse C. So if I try A squared plus B squared equals C squared, I don't know A, so that's going to remain A squared. B is 12, so I'm going to put in a 12 squared. And our hypotenuse is 15, so I'm going to put in a 15 squared. Remember, your hypotenuse is always going to be your longest side length as well, so that you can kind of gauge your answer and make sure it makes sense. A squared I can't do anything with, so that's going to stay in A squared. 12 squared is 144, and 15 squared is 225. When I subtract 144 from both sides, my 144's cancel, and I get a squared equals 81. To get rid of an a squared, we square root. What I do to one side, I have to do to the other. Square root of a squared is a, and square root of 81 is 9. So my missing side length is 9 feet. And on to our last example. This time it's our hypotenuse that's missing. So again, I'm going to name the two legs A and B. Order doesn't matter as long as one of your legs is A and the other is B, and your hypotenuse is always C. So again, Pythagorean theorem is a squared plus b squared equals c squared. I know a is 6, I know b is 10, and I don't know c. 6 squared is 36, 10 squared is 100, and c squared has to stay c squared. 36 plus 100 gives me 136 equals c squared. To get rid of the squared, I need to square root, and what I do to one side, I do to the other. And this time I need to bring in a calculator because 136 is not a perfect square. So we're going to have to estimate this time, right? The square root of 136, I'm going to round that to the nearest tenth and make that 11.7. So C is about 11.7 yards. And there's my solution. Just a reminder to write down any questions that you have and bring them to class. Don't forget your online quiz, and I'll see you in class. Have a great day.